Cohen. I'm the Chief Data Scientist and one of the co-founders of Anodot. Anodot is a 3.5-year-old startup based in Ra'anana. I'll talk about the real-time journey from raw streaming data to AI-based analytics, and this is really what we are about, AI-based analytics as a company. And I'll discuss some of the use cases. Now, some of the slides you're going to see today are from a joint talk I gave last week with Roy Ben-Alta, who's at AWS. He's part of the business development for Kinesis, heads the business development for Kinesis. And because we're talking about live raw streaming data, I wanted to show Kinesis as one very good way of sending live data to various systems, but in particular to Anodot. All right, so let me go back here. All right, so what is the pain that Anodot tries to solve as a company in our service? The pain is that delayed or missed business insights cost companies millions of dollars. And I like the tagline, which is, you don't know what you don't know until you know it. So not knowing something doesn't mean there isn't a pain, doesn't mean that you're not losing something. So at the same conference we talked together with Roy from AWS, there was another talk from head of data science from Uber, who talked about their solution, the in-house solution that they built. So Anodot detects business insights by using anomaly detection. Uber realized that anomaly detection is really critical for their business already about 5 or 6 years ago, and have had a team working on it for the last 6 years. For them, it's mission critical. In that slide, the guy from Uber actually said anomaly detection for Uber saves around $8 million a year. So the fact that they have an automated system that finds out automatically things that finds out these business insights automatically on their massive scale data saves them $8 million a week, and that was a conservative estimate. So this is not something from our marketing. This is something that I saw last week from a company that's not even using us, but they built their own, which is actually quite similar to what we do. All right, so that's that being said, that's the pain we're trying to solve. The existing solutions that are out there today, both in the DevOps, but especially in the BI world, which are our target audience as a product, are BI tools, dashboards, reporting, and really this caricature illustrates what's the problem with dashboards. When you have a large business with many moving parts and you're measuring things, it's high granularity, and you start creating more and more and more and more and more dashboards that people have to look at and eventually get lost and miss things. These dashboards are not there for nothing. They're meant for the people to detect that there are things going on that they need to pay attention to. But if it becomes too large, it's hell, and you miss out a lot of incidents. And then it costs millions of dollars eventually. So what does Anodot do? We use unsupervised machine learning algorithms to learn all the data's normal behavior, identify abnormal behaviors, score the impacts, correlate all the affected metrics, so root cause investigation is done fast, and alert on it. So that's what we do in general. Now we can go into a little bit more into the details, and eventually, and then I'll start talking about the real-time aspects of detecting these issues. So let me start with an example, and I actually gave this example not related to Uber's talk last week. It was an example about a ride-sharing company that sits in San Francisco and operates in many, many cities. Now, if there is what's happening when you try to order a ride in the rain. From the rider's side, he might be standing outside, she might be standing outside getting wet, waiting for the ride to arrive. But from the ride-sharing app side, today they're sitting in front, lots and lots of screens, looking at many cities and many different KPIs. And if she's lucky, they detect that there is something going on in Nashville that's causing delay in rides arriving, and then they can do something about it, like incentivize drivers to go out and take more rides by either giving them money or increasing prices, various levers that they have. But if they don't know about it, they don't know about it, and she's standing out in the rain. How would we like it to look like? The operator, the ride-sharing app operator, would like to get an alert saying, look, there's something going on in Nashville. The wait time for a ride increased abnormally, while the driver utilization, meaning the number of available drivers, also increased abnormally. And then once you get that alert, and the faster you get it, the faster you can react to it, you can actually do all these actions, increase drivers' incentives usually in some apps, or increase prices in other apps. But you do something to alleviate this problem. So that's one example of how anomalies can help you detect these incidents and react to them quickly. So let me actually show you a demo of Anodot, and then we'll go to the real-time aspect of it and how do you actually start getting these anomalies in real time. So the demo is really to show you what Anodot does from historical data, actually. So before I go there, any questions so far? Open the...
No, I don't see any questions.
Oh. All right. So let me go to the demo. This is the next demo. All right. Actually, so here's an alert that our system produced from for a ride-sharing application. It basically tells you here on this date, and like I mentioned, this is not a live demo. This is looking at historical anomalies. Here's an alert: ride-sharing app, ride cancellations has increased. And so that's the alert. You get it in real time when this thing happens, and you can get it via email or via other means like to Slack or webhooks to any other systems, PagerDuty or anything like that. Then in the alert itself, you can actually see that why did you get the alert. So here is the number of ride cancellations in LA for users using mobile devices, Android mobile devices actually. And you can see a spike in ride cancellations. Here is this, an increase in ride cancellations of users from New York using mobile Android devices. And again, it's a different pattern, but what you see here, this is the actual values. The shaded area is what our system learns as the normal. So anything that falls inside this shaded area is considered normal. It's not an anomaly, so there's nothing to report about. But when it goes out of that range, that's something that's worthy of reporting. LA, mobile Android for premium ride types, for shared ride types, increase. So there are increases in cancellations in various KPIs. So for ride cancellations in various granularities. So for different cities, for different ride types. So this tells me there is something going on that's not related to a certain geography. Let's go investigate it further inside the system to get to understand why these ride cancellations happen. So everything that I'm showing you now is a regular flow of users using any anomaly detection system that also alerts on them, and specifically ours. So when I go to investigate, it actually takes me to the full anomaly. And what we do at Anodot, we actually correlate automatically. So like I mentioned, this is an historical anomaly. When you get the alert, you actually see it this far, or probably even only this first point. What we do at Anodot to help you actually find the root cause much faster, we correlate anomalies that seem to be related to each other. And what does it mean to seem to be related? We have algorithms that continuously look at all the patterns of behaviors of all the metrics and KPIs that are sent to Anodot and determine whether they are correlated so they can be grouped when something happens. So in this case, there were actually 25 of them grouped together. The alert said there was an increase in ride cancellations, but I also see that there are anomalies in ride request time. I see that there are anomalies in HTTP errors. I see there are anomalies in driver request API errors. meaning there is an increase in the number of errors for requesting drivers. And I also see an anomaly related to write completed. So let's look, for example, at the driver request API error anomalies that are in here. So what I see is there are always errors. So it's not, so any API has sometimes errors because of all sorts of reasons, but there is a normal patterns to the errors, to the number of errors. In this case, the increase that happened at the same time with write cancellation, there was an increase in that. That was also abnormal compared to what's considered normal in history. Now this tells me as a user for the investigation part that the write cancellation is probably technical related, so it's not whether there isn't rain. I also see here we have a component that actually highlights what are the dominant dimensions for every anomaly for every metric, and what I see is that it's related to the version of the app for users using Android devices, mobile Android devices. While it's in multiple cities, multiple type of rides, so that means to me that it's probably not something related to geography. So as opposed to the example I showed in the beginning, Nashville raining, this is not New York and LA are so different, it's probably not weather related. It's not even a certain type of ride, so it's not a certain type of drivers that are also all of a sudden not showing up. But it's related to Android mobile and version. So that's very strong indication to go to my R&D or to go to the development team that's in charge of Android and tell them what's going on, why on this version of the app there's more cancellations happening. What we do at Anodot, we also correlate it with events. Events are things like deployments or anything that are discrete, so not something you measure over time. In this case, I see there is a correlated event that happened just before this anomaly started. And if I look at this event, I see it's a deployment type of event. It could be a holiday, it could be rain, it could be any type of event. But this is a deployment event that says there was a change in nearby driver API implemented for all mobile devices. So there was a release of a change related to the driver API, and it looks like it broke something, or sometimes it breaks on Android devices, because the metrics that were correlated with it are also errors with the driver request API. So that's, with that information, actually R&D has a much more detailed information about what to investigate and how to investigate. So it brings me much closer to the root cause. So this is a normal flow of the way we use and our customers use Anodot today, day to day. They get an alert, they start investigating it, they send it to, and then they handle it. It could be a technical issue, it could be other issues. It could be a positive thing that you can take advantage of, so not all anomalies are bad, but the normal flow, alerted, investigation, fix. Any questions so far?
No, I don't see any questions.
Okay, no problem. So let's go back to the presentation. Now that we are, that you kind of got the feeling of how Anodot looks like and what does it do, I'll continue and explain how do we do it. So again, Anodot works by learning the normal patterns of every single metric that gets sent into our system. And it's done automatically with zero configuration. Then it detects anomalies in these metrics. It correlates anomalies to help investigate the root cause using another set of algorithms that do that learning. So what you see here, the shaded area again is what our system learns. Orange are anomalies detected, and the fact that they're shown together helps you with the root cause investigation. So why is this hard to do? To build such a system, and I don't know of many companies that have built it themselves at really large scale for all the metrics. You have to take care of several things. You have to be accurate and robust, because like any system that detects things and alerts on them, false positives are really killers of it. And as opposed to static threshold type systems or static threshold that you might be able to apply on things like CPU or memory or response time of a web page loading, where you know anything above 2 seconds is too high. when you're talking about various KPIs, especially related to business or alike, that's driven by users, they can have many different shapes and types of signals that look very different, and the system has to be robust to it. It has to be robust to any type of signal, so you have to have very robust algorithms that can handle all types of signals automatically. We have to be robust to changes, because changes occur all the time, especially in digital companies that keep changing. And it has to be scalable. So for example, Uber has around 300 million metrics. Facebook has around 10 billion metrics, or it had 10 billion metrics a year ago. I think they pretty much double it every year or two. So it has to be scalable, and scalable in the sense, not just in the sense of being able to collect the data, but also to analyze the data with no need for configuration or data science expertise. Otherwise, you're left with configuring an alerting system all the time, which is impossible at that scale. And even if you have 100,000 metrics, it's still impossible to manually do and try to configure that system. The last one is related to being able to enable root cause investigation. So the fact that I alert you on riot cancellations, if I don't couple that with other anomalies that help you understand why it happened, then you're still left with a lot of manual work on trying to investigate. Also, if you have lots of different alerts and you don't group them together, you're going to be flooded with many alerts, and you're going to have basically, even if it's a real issue, you won't see the forest for the trees, and you'll be just lost in all these different metrics that are anomalous without knowing what is related to what and what helps me, what is one issue and what is another issue. So that's really critical as well. And doing all of this at high scale is not an easy task. So some of the use cases that we've seen that are very, excuse me, that are very important for use of anomaly detection. So any data-driven company needs such a solution. Now, depending on the scale and size of the company, it might be something you can manually do in-house, or you might need to use an external company for it. But the use cases that we've seen that are very strong, anything around online payments and loans, where you have a lot of transactions, like drop-in transactions across partners, mobile devices, types of loans. Ad tech has a lot of real-time need for anomaly detection, because anomalies can cost quite a lot of money quite quickly if there are issues. For example, if a publisher leaves you, you want to be aware of it. If your bidding algorithms start having glitches and they start bidding incorrectly at fast rate, you might lose a lot of money very fast, so on. E-commerce, obviously, drop-in conversions, reservations across countries, so the granularity is very high, and telcos. Some customers that use us today, and I think this is my last more or less marketing slide about Anodot, are a variety of customers ranging from e-commerce to telcos to Lyft, to ride-sharing, to ad techs like OpenX and Rubicon Project and AppNexus, WeWork. What's in common to all of these companies that they're very data-driven in their decision-making, and they want it fast. They need it fast to make decisions quickly, because missing out on potential incidents or opportunities costs them quite a lot, and they are aware of it, just like Uber mentioned that in their slides. All right, so how do we do anomaly detection at large scale? So questions so far before I go into the technical details. Maria, are there any questions?
No, I don't see any questions.
Okay, no problem. So how do we do what we do at very large scale? So this is our high-level architecture. We are on AWS as a company, but there's really not much in here that's tied to AWS. So we've been able to run it on Google Cloud and other environments. The way it works is data gets streamed into our system from whatever data source they are, and I'll touch on the data source in the next slide. It hits our streaming engine, a streaming learning engine, which basically takes every data point that comes in and starts and compares it to what we already learned about that metric. If it falls into the normal range, the expected normal range for that data point at that time, then it's not an anomaly, everything's fine. We actually do online learning, which means we update the models as data flows in, so the models keep getting updated with every data point that comes in. And that's how we are able to actually scale our system quite high and produce anomalies at real time. And then the data gets stored. We use Cassandra as our data, as a real-time data store, very fast for reads, and that's most of the things that we do into Cassandra. We do reads. Writes, not reads. So we store the data in Cassandra, and we update the models when we also store the models into Cassandra as well. Now, why do we do everything online? So as I mentioned before, part of the requirement, besides being real-time, being able to detect anomalies in real time, is being able to detect anomalies on any data that gets sent. If you have 1 million metrics and you send 1 million metrics into our system, we want to find anomalies in all of these 1 million metrics. If it's 10 million, it's 10 million metrics that we have to find anomalies in. And why do we need to find anomalies in all the metrics? It's because that's the nature of anomalies. If you don't know you don't know which anomalies will happen when and where. You don't know what you don't know until you know it. So you want to detect it anywhere where it might happen. So if you think about it, if we had to store the data in Cassandra and then pull it out for analysis afterwards, we would never be able to scale in any economical way because once the data is at rest inside our database, it's already very hard to pull it out. So Cassandra, you can optimize it for writes, you can optimize it for reads. It's hard to optimize any database for both reads and writes. And if you're trying to analyze all the data all the time, it's better to do it before it goes into any database. So that's the nature of it. Besides, it gives us a way to, we anyway have to use adaptive algorithms to find anomalies. So doing it on the stream, it's actually good both from the machine learning perspective, but also from the system architecture perspective and scalability perspective. So that's this main cluster here, and it really does a lot of the learning on the stream itself, and it works. It's completely scalable and parallelizable because we work at this phase on every metric individually. So once we detect an anomaly, we actually send this anomaly into another cluster. We call it Arnold because after Arnold Schwarzenegger. It's a much smaller cluster that does a lot of heavy work, but we were able to make it very efficient, so we were very proud and decided to call it Arnold. And Arnold, what it does, it takes in all these anomalies, anomaly events for any metric, and here it starts to do the grouping, to understand should an anomaly from the right cancellations in LA be grouped with the increase in the API errors for the same city or in any other city? Should they be grouped together into a single anomaly that defines a whole anomaly story or group? And here basically we hold in our belly this relationship graph that tells us whether different metrics are related to each other. How do we get the graphs? We get the graphs, this relationship graph, using another set of clustering algorithms that get run daily as an offline job using Hadoop and Spark and a set of algorithms that we developed ourselves for doing this correlation. So if two metrics now are anomalous and we've discovered in the past that they have a relationship, they should be grouped together, then they get grouped into a single anomaly. and then they can be alerted on. And what we do is we use Elasticsearch as an indexing and search engine for indexing all the anomalies that we found in the system. So in the UI, when you see it or when we send an alert, it's easy to pull it out pretty quickly. So in terms of data, Cassandra is for the raw data, for the actual time series data. Elasticsearch for indexing and search of metadata about the anomalies. And these components are things we built our own. And as I mentioned, we also have some offline jobs that run every day to discover various things about the data that don't have to be discovered in real time. For example, whether the metric has seasonal patterns or not, what type of signal it is, and if it changed from yesterday, the grouping, and so on and so forth. Questions so far?
Anyone has questions? Or no one wrote anything?
And Maria, if you have questions, you can ask them. Yeah, of course.
All right.
All right, so I won't go into the details of all the algorithms. We have some various both online presentations and videos that actually drill quite deeply into what algorithms we use and how we build them and how they interplay with each other. Various white papers and videos online. So feel free to go and search for it. But what I wanted to talk about is the integrations to various data sources. So today we know how to integrate to a lot of different data sources where people hold data, and what I wanted to illustrate here is, besides being able to integrate with a lot, the reason Amazon Kinesis here is kind of larger. One reason is because I gave a talk with somebody from AWS, and we want to talk about Kinesis. But the other aspect of it is the real-time aspect of a pipeline like Kinesis. So if you look at some of these sources like SQL Server, MySQL, Redshift, maybe not Google Analytics, but Vertica and BigQuery and Elasticsearch, all of these sources of data are data at rest sources. It means that when the data gets pulled out of these sources and gets sent to Anodot, they probably already had some latency around the data because of the ETL process that occurred to push it into these type of data sources. Some other data sources that are not like that are, CloudWatch or Mixpanel or Google Analytics, which can be more real time. CollectD, definitely, Coda Health, Metrics, Graphite, they can be a lot more real time, but they're not streaming data either. They're all going into some other process, especially Mixpanel or Google Analytics. If you look at live streaming data, pipelines are actually, you can at much higher rates into Anodot or other type of analytics system, and the advantage you get with a system that finds anomalies and does that data analysis continuously, like Anodot, is that you actually can get your insights in really near real time, up to 1 minute latency. That way from what we have seen so far. There are other systems that do live streaming like Kinesis, like for example Apache Kafka, so Kafka streaming. It can be connected to Kinesis as well, like this slide illustrates, but really what the service, meaning that if you're using AWS, Kinesis does a lot of data wrangling behind the scenes, even for your account. And that's for the metering, any S3 events, CloudWatch logs, Amazon.com catalog, everything today at Amazon goes through Kinesis. So regardless of whether you're actually using it for your events, your account is using it no matter what. So like I mentioned, foundational services. Streaming with Kinesis has, they have various services, video streams, which they added recently, data streams, which is what I'm going to talk about, Firehose, which can actually load into various AWS data stores, and data analytics that lets you do SQL on the stream itself. And that's really some of what's needed for sending data into Anodot from your events. The advantage really from what we see from our customers is it's serverless, so you don't have to install anything. You basically go to AWS interface and you can start using Kinesis. No administration, you pay for usage. Latency is very, very small. SQL is easy to use. Don't need to be a programmer to use it, which is really great if you have a group in your company that needs the analytics, but is also with any other, cannot get the resources from DevOps or the R&D. So with that pitch about Kinesis, let me show you how actually Anodot, how you integrate your event stream that you flow through Kinesis into Anodot and actually get alerted on something that happened. So what I'm going to do, and it worked at 5:30, so half an hour ago it worked. Right now, God knows if it will work, but let's say you're in e-commerce selling various products, and you have now an issue. The issue is a price glitch. You accidentally, and price glitches happen constantly at various e-commerce sites, from travel to products to anything like that. Somebody makes a mistake, so for some reason a product gets advertised or gets sold on your site for a lot lower than the actual price. Dell laptop is now being sold for $64. Various web crawlers detect that, publish it on various websites. It goes to Instagram, Twitter, Facebook, gets published, people subscribe to it, and they go and start buying. So that's the price glitch. And the faster you get it, the faster you fix it, the lower the damage. In some cases, you might have to honor your sale. In some cases, you might not honor them, and then you lose customer satisfaction. And I mean, nobody likes to be told that what they bought, they have to undo it, even if it was a glitch. So sometimes they honor it, sometimes not. In any case, it's never a good thing. So what I'm going to do now, I'm actually going to create this price glitch. So just to help you understand what's going on, I'm going to open. So basically, what I have running here is events being sent into Anodot constantly, and these are the normal events. So the events are related to basically sending how many times people clicked or added to carts and bought various different items. And I can't move this window, otherwise you would see that different categories like laptops and like any site. So these are being streamed right now into Kinesis and then into Anodot as metrics that are measuring how many clicks and what were the average price per product that's being sold. How many clicks, starts, how many buys. The way these metrics look like in Anodot is this way. So this is actually the price glitch that I automatically did half an hour ago. So right now the data, I hope it's still live. It sometimes kind of stops. Yeah, it is. It stopped at 6:01. Let me resume the data feed so you will able to see the actual So they have a data generator, and actually this part doesn't work very well. The data generator is just for demos that they have built, Amazon Kinesis data generator. And for some reason, sometimes it loses focus and stops sending the data. So let me resume it. So here you can see various types of products. This basically creates a JSON that sends how many times footwear was clicked on, added to cart, and bought, what was the price, and here it's basically I'm generating a random price for every item. So it's not real data, but I'm going to send it in. And the way it looks like inside Anodot, basically in 1 minute we'll actually see a continuation of this line. So this is the number of buys for toys, and this is the number of buys for laptops that were generated. So what I'm going to do now is actually the price which just happened, was announced, and people are starting to buy, which means they're going to come and they're going to buy laptops. Let me put the price that we have there, $64 average price. And of course, because this is a price glitch, you tend to see a lot more people doing it. So I'm going to start sending this extra data that will cause an anomaly in the system, and what we'll see is the alert that will come out of it. All right. So while this is happening, and the alert will come in about 1 minute, 1 minute after we start, like I mentioned, it's near real time. So while we're doing that, let me explain how you create all these data streams and integrate with Anodot. So any questions before I go into that?
No.
Okay. So as I mentioned, I have a mobile app. I'm sending events. So any event that people do on the mobile app, like clicking, buying, adding to carts, gets sent to Kinesis as a stream. So basically, every event in the stream has the event type, the timestamp, the product price, and the product type. And based on that generator you saw, you will get different numbers for different type of items, and that gets sent into Anodot. So that flows into a Kinesis stream. Now, how do we take that stream and transform it into metrics that get sent into Anodot, like the metrics you saw before? So the first step, the first step was to send your events into Kinesis. That's the first step. The second step is to use Kinesis Data Analytics to create an analytics function. So you want to do some aggregation and over that data, so it can be sent into Anodot, over those events, so it can be sent to Anodot. So this is a screenshot from how it looks like, and let me show you how it looks like in reality. So let's look at it here. So basically, you go into your Kinesis console. So this is how it looks like in reality. You can see the streams that you have active in your account, and this is that stream that I'm sending data into, called demo input stream. And now I want to create something on top of that demo input stream. I want to create an SQL on top of it. So this is the actual application that I'm running. And let's look at how it looks like. So the first step is to determine what is the source. What is the source for this analytics function that I'm going to create over top of the events? So here, you basically choose from the available streams that you have. And you can actually have multiple streams. And here I chose demo input streams. Now you create your SQL that will aggregate those raw events into something that can be sent to Anodot. So this is the SQL, and really no coding required. You just need to know SQL, and it's a simple aggregation to do to Anodot. Basically, you select a stream. You say, I want the average product price. I want a count. I want the count of the events. And you say what is the bucketing that you want. In this case, we bucketed it into 1 minute intervals. So basically, it's counting how many events happen every minute, and what's the average price for every type of event based on those properties, like the type of event that happened and the product that we had. This is the result, and then you can actually see resulting examples. This is the actual aggregations that happened over the raw that happened in the last minutes. This is actually the source data. This is an example of the actual aggregation. You will see results in 2 to 10 seconds. Every 2 to 10 seconds it refreshes the result. When you create this analytics app, it's very easy to debug it, and you can see results and understand whether you got it right or not. Let's give it a few seconds. So here, we already see 66 laptop clicks, 10,000 events that happened in the last minute. So now this gets streamed into another Kinesis stream. So that's, if I close this, go back to the exit. So that's the last phase. You set what is the destination, and you can send it to another stream. And actually today, Kinesis is now allowing you to send it to have a Lambda function that gets connected directly with an analytics function. So you don't even have to send it back to a stream, but you can just send it to a Lambda function, and that gets sent to Anodot. And that's really the next phase, applying a Lambda function. So the whole goal of the Lambda function is to take the aggregations and using a small piece of code that we provide, transform it into Anodot's API and send it to Anodot. And we have a RESTful API for sending data. That's this Lambda function. The way it looks like is the way you define it is basically you define a sentence. You call it, you give it a name. You say which Kinesis stream it should use for it. You upload the function that we provide, which is basically a Python file that takes any type of stream and transforms it into our RESTful API. All you have to define in here is environment variable. So where you're which environment, so where you're sending it, your customer token in Anodot, what are the columns, the dimension columns, the metric columns, and what is the timestamp. And then the code takes care of that and sends it into Anodot and creates metric in Anodot. Now, this whole process, first of all, does not require any coding because the only code that is here is being provided by us and can be done by anybody. Anybody. You need to be technical to do this, of course, but you don't have to now install servers or install software, write code, or anything like that. SQL, knowledge of Kinesis, and you're done. You can start sending live data into Anodot. Questions so far?
No.
Great. So let's see what happened. Let's see what happened here. So actually what we see is that, well, let me see if we got the alert. It should be somewhere in my trash probably. The alert on the anomaly that happened. So here is an alert that came out at 6:41, so while I was talking. And basically the alert says there is a suspected price glitch. What we see here is an increase in the number of events for certain products. Well, I think this is the wrong, oops, just a second. Okay, so live demo. For some reason it sent me the wrong alert. But let me show you the alert that happened on 5:30, and hopefully you'll believe me. It usually happens okay in real time as well. Here, because of the way I sent the data, I'm not sure that it even went in correctly. So let me go back to alerts. And let's look. So this is the alert that came out at 5:32, so about half an hour before we started this session. It says that there was an anomaly that started at 3:30 UTC time, so that's 5:30. So 2 minutes before the alert actually landed in my inbox. And what I see here is that there is a spike in number of clicks to laptops, add to carts. So the product price, actually the average product price dropped dramatically. So it's usually steady unless I have sales, but here it dropped dramatically, while the number of people clicking on it, adding it to cart, and buying it increased dramatically. Now, if I'm doing a sale, then this is okay. This is a normal pattern. But if I'm not aware of any sale, this is definitely a suspected price glitch. And as this text says, it says, increase in number of purchases and decrease in prices. And I don't see any event correlated with here that says we had a discount event. So if there's no event, I better go and investigate it. I could go into Anodot. It's probably there is no need to look at any other metrics that are correlated because the alert tells me everything. It's actually, I need to open it in my other window, my in-person. So I'll open it here. So what I see here is, the anomaly that happened. This is actually the price glitch I just created while we were talking. It created an anomaly as well. I'm not sure why the alert didn't come out as it should have. But this is the anomaly from 5:30. And what you can see is I got alerted. If I discover that it's a price glitch, I can go and fix it. And what I expect is that everything will start going back to normal. So average price went down. Number of events, people interested buying and adding to cart went up. The faster I fix it, if it's a price glitch, the better for me. The better it is for me, because then handling these fewer customers might cause less of an issue. Either I cancel their order, but it's less customers that are pissed off, or I honor it, and they won, but at least I'm not bleeding now for several hours or days sometimes. So that's really the importance of the real-time nature of getting these anomalies really, really fast. Questions?
Not yet.
Okay. So almost done. So in summary, real-time streaming data is really critical to understand what's happening quickly. Using tools like Kinesis, Kafka streaming, or any other streaming system that streams events. So when you're looking at dashboards, it's critical to see what's in the dashboard really fast, but then you have to have your eyes on it. If you're applying any system that does anomaly detection and you want to be alerted really fast, it's also important, because it's probably even more important, because now you have to stream massive amounts of data if you want to understand what's happening anywhere in your environments, in your events, or any metrics that you care about. And then being detected faster, streaming it faster becomes even more important for such systems. So some future applications are things like analytics, devices like IoT devices, and more. And as they like to say in AWS, the future is now and it's fast. And it really is fast. The faster you react, the faster you, the better your business is. So with that, I'm going to stop, and if there are any questions, I'll be happy to answer. And of course, even if there aren't any questions now, feel free. It's my email is ira@anodot.com. Send me emails. I'll be happy to answer them. And if there are any questions now, please let me know.
I don't see anyone asking questions.
Okay, no problem.
Thank you. Very interesting potential. That's
You're welcome.
Thank you.
And thank you very much for those attending, and I hope it was interesting.
Thank you.
Bye-bye.
Thank you for an interesting session, and have a good evening. Bye.
Thanks. Maria, I'll stay on the line if you want.